Okay. Hello, ladies and gentlemen, and welcome to our session, How to Provide Kubernetes Service in the Cloud Provider Space. Well, my name is Reinhard Portman. I'm here with my colleague Tobias Paschek, so let's introduce ourselves. So, like I said, we both are from Austria, small little state in the middle of Europe. I mostly do multi-cloud, EUC and networking, and my colleague Tobias is...
Hi, my name is Tobias Paschek, or just call me Toby. I'm mainly focusing on the whole cloud provider networking space, but also nowadays on the whole application modernization part, so providing Tanzu services inside VCD.
Okay, so what's the agenda today? Basically, we are looking about Kubernetes services in the cloud provider space. We have a small agenda, and then why do we do that? How do we do it? And lessons learned a little bit, right? So let's get started. So the Com Division Group, we have been founded in 1996, so relatively long on the market. We started out as a strong VMware partner, having a long time commitment with them. And yeah, we do projects. We have strong focus with VMware partnership in Austria. We have Austria, Germany, US, and in Belgium offices. And we also educate and operate because most of us are also VCIs. So basically we design, we educate, and then we also operate multi-cloud environments. At the end of the day, we are doing VMware stuff all the day. And lately with all the multi-cloud, a strong partnership with AWS we have signed up to. So at the end, why should a cloud provider do KaaS?
Thanks, Reinhard.
So,
it's a good
tell me
question.
something about it.
So, more and more customers really asking for Kubernetes services. Especially from a cloud provider perspective, there are two options available. We offer them self-provisioned, so we offer them directly from a VCD perspective, or you tell your customer, hey, just go to AWS, just go to Azure, go to GCP. Maybe the second option is not the best way, because if the customer figures out, hey, how easy I can provide Kubernetes on GCP, AWS, wherever, for what do I still need my cloud provider? Because I still have the capability to get VM services from GCP, from AWS, whatever. So maybe we should have a deeper look how we can offer Kubernetes services. On the other hand, customers are not really able to wait more than one day for their Kubernetes environment. So it must be instantly ready. So there must be a self-provisioned way where the customer brings in the necessary information and then ramps up his Kubernetes environment. Also, and this is maybe for some cloud providers, some, let's call it exciting news, VCD is changing. VCD more and more is going into the Kubernetes world. So I assume, but this is just an assumption, that in the next couple of releases, also the native VCD services will be provided from a Kubernetes perspective. And last but not least, and this is what we clearly see with the latest release of 10.5, Kubernetes is now fully integrated into the Cloud Director space. Reinhard, back to you.
Okay, how those cloud providers are now providing those services to their customers? At the end of the day, what do you need? You need your base infrastructure set up and configured. Basically, we are talking vSphere, we are talking NSX, we are talking VCD, right? So, on top of that, we need to have NSX ALB fully configured, integrated into your environment, because Kubernetes will leverage those services through the API. Cloud Director also needs to be fully configured. You have to have your physical VDCs, your organizational VDCs. You need to have all the edges set up, NSX set up. Think about all of the overlay networks, right? So what else do we have? The customer organization's resource allocation models. Think about that, because many things can go wrong with that stuff. Yeah, edge gateways, routed networks, load balancers.
So as you can see, it is really a broad scope, what we need to leverage, what we need to figure out, and how we can utilize this. So it is not really an easy way, but we can solve it and you can provide it. As always, please, please, please have a look to the interoperability metrics, because this is really here also the important part in the whole CSE story, that we have the right cloud director, that we have the right CSE version, NSX version, NSX-ALB, and so on. So please, as always, take a deeper look into the interoperability metrics to figure out what versions are compatible. This is something which hopefully gets changed in the next releases, that more and more of this interoperability is then easier to solve. So what are the problems we have encountered, or what are the problems we have seen? On one hand, it is, let's call it an organizational problem. Many service providers try to offer a managed Kubernetes offering, which is not necessarily needed, especially for you as a cloud service provider. You know how the infrastructure is working. You know since ages how Cloud Director maybe is working. If you don't have really the teams or the guys in your company which are aware of how Kubernetes is working, try not to offer a managed solution. Try still to offer, say, hey, okay, dear Mr. Customer, you need Kubernetes, no problem. I have an automated deployment solution for you. All of the build, run, architect, develop, and stuff like is happening in Kubernetes still is your fault or is your problem, not my story I try to solve. If you are in the big deal that you say, hey, okay, I have a whole bunch of teams which are capable of playing around inside the Kubernetes world, okay, then you still can offer a managed solution. But many customers still requires just to have a Kubernetes environment where they can build, develop, run their, or architect their applications.
Next steps, ALB deployments. Take care of that, make it thorough, think about it. Again, back to the drawing board if necessary. Do your designs right, think about it. What do you want to achieve? What are your business requirements? Go through all the steps again. And network design, what did we see there? A lot of stuff going wrong. Again, it's all the things you miss at the start. They will kick at some point your six. They will hunt you and they will find you those problems. So think about it.
Thanks, Reinhard, for ramping it up. Let's have a deeper look into the whole ALB story, because I know it is quite something new, especially in the cloud provider space, because NSX-ALB, or Advanced Load Balancer, has been introduced a couple of months ago to Cloud Director. Let's have a look to the network, and let's also have a look to what we encountered. Okay, so let's start with NSX-ALB.
So, controller sizing. You see we have a couple of controller sizes available. Small and medium, well, they are not for production sized. For productions you have large and extra large, but in our case go with extra large, because at some point you're running all the services are reporting back. You have the service engines, you have the API calls, and when you go in a horizontal deployment, well, guess what? All of that stuff multiplies. And then there is your bottleneck right there, right? So production environments, extra large. Yes, it consumes a little bit of CPUs and RAM. On the other hand, better consume a little bit more resources than lose or having timeouts or whatever other things which can go wrong, right?
Right.
So,
on the other side of NSX-ALB, because NSX-ALB, as Reinhard already mentioned, is also a distributed system. So I have my data plane, which is the service engine, and I have my management plane, which
correct.
is the ALB manager, or the NSX-ALB manager. The service engine itself comes by default with just a single vCPU core. It is something we can reconfigure, but there is a pitfall, and I will present you why there is a pitfall. The one vCPU service engine still have some impressive numbers, so we can have up to 40K sessions. We can have a throughput from 2.5 gigabit. We can have up to 950 SSL transactions per second with RSA 2K, or we can have up to 2,900 SSL sessions with ECC. But especially when it comes to Kubernetes, I have the API. Everything my developers are doing runs against the API. So I have from a starting perspective, already a high amount of SSL transactions or calls against the API. All of my services, for example, my Node.js, my whatever container I have, needs to have the load balancing services. So I instantly ramp up my services, and I instantly also ramp up my sessions which are running against my load balancer. And that's the reason why we need to go with the 2 vCPU service engine at least. Higher amount is always possible, but at least we need to start with the 2 vCPU, which brings us to more throughput, more SSL transaction. And to be honest, I don't care about 2 vCPUs and 2 gigabyte of RAMs anymore, because I think, especially in this cloud provider space, this is something which can be easily solved or should be solved. These are not numbers we encountered or we figured out. Yes, we encountered it also in a production installation, but these are numbers which comes from the VMware validated design. So for those who are really interested in how the whole design process has been, there is the VMware validated design available for CSE 4.1, and there you will find all the matching numbers or all the design decisions I just provided to you. On the other hand, there's also quite a decision solution available. I can deploy my service engine in 2 different manners. I can deploy them as a so-called shared environment or as a dedicated environment. Also here, the answer is it depends. If you say, hey, okay, my customers are fine, that they are maybe not fully separated, that there maybe is a possible way that traffic runs only on the service engine level, we can go with a shared environment. If you have some customers, let's do the typical example, Pepsi and Coca-Cola, and they say, hey, we need to be fully separated, nothing is allowed to be shared, then we need to go with the dedicated solution. Dedicated means we have more services engine, which means we need more resources, yeah, as always. Let's move on to the container service extension design. What do we need to have here in mind, and what do we need to have here in place upfront? Because some of the stuff is necessary. Reinhard, what can you tell us?
Well, you need the feature service organization. It's a new feature from 10.5, right? Leverage that. Read up in the documentation, go through the release notes. Well, routed networks, of course, you need all of those edge gateways, and as the Kubernetes service is contacting the Cloud Director API services from within, you need to have firewall rules in place, you have the source NAT outgoing rules in place, and especially for firewall rules, DNS UDP, port 53, everyone knows that, HTTP, HTTPS, TCP service, no news about that. And because the service engine is also contacting the public catalog and talking through the Cloud Director to pull them and deploy them, well, the connectivity needs to also be there.
And also on the other hand, this is the part where all of our possible Kubernetes releases get stored. So the published catalog or the published library is really here the important part, because this is the part where you can store all of your images, and the customer then can decide, hey, I would like to go with Kubernetes 1.18, oh, I would like to go with Kubernetes 1.22, I would like to have 1.24, whatever. And this is also the freeness the customer gets. He can decide what Kubernetes version he would like to utilize or he needs to have in his production environment. Let's have a look to some of the prerequisites that we can figure out what we need to have. As Reinhard just mentioned, we need to place the source NAT rule, because the whole Kubernetes stuff needs to be capable of reaching the Cloud Director API. We will have a look in the network diagram in a couple of slides. So first of all, what we need to, or what the customer, because this is also something the customer can do by itself. First of all, the customer needs to create the SNAT rule. The customer needs to create the necessary firewall rules, as Reinhard just mentioned before. At least DNS, UDP, HTTP, and HTTPS outbound must be allowed. Otherwise, the CSE deployment will fail, because the CSE is not capable of reaching our Cloud Director. Let's have a look to how the stuff is working. as we have our tenant, okay, as always, we have the organization VDC from our tenant, and the tenant now decides, hey, cool, I would like to have Kubernetes. So he ramps up, he connects, he goes to his tenant portal and says, hey, okay, I would like now to deploy my Kubernetes environment. What's happening in the background is that the Cloud Director API is triggered. All of the stuff in the underlying vSphere world, NSX world, NSX-ALB world is done fully automated by Cloud Director. And then we go to our CSE catalog where we have stored all of our images, and automatically we ramp up a Tanzu Kubernetes cluster inside the organization VDC of the customer. So it is nothing shared. It is really in the organization VDC of the customer. So you can immediately charge him as always, because he is consuming VRAM, he is consuming CPU, he is consuming storage. So nothing changed really from a pricing perspective. The only thing which has changed, because he is now also utilizing load balancing. Okay, maybe he needs to pay you more for the whole load balancing stuff, and you maybe also get additional points charged to VMware. But everything is really running directly in the organizational VDC of the customer, and not some magic outside organization or something else. It's really seeable from the customer perspective. The customer can still power on his VMs and stuff like this, but at the end he gets an API entry point inside his organization where his developers then can start whatever they would like to do. So in total, it looks like a full bunch of mess, but at the end it is not, because there is nothing new. Still, we have our provider-managed edge cluster, where we have our tier 0 gateways, or our tier 0 gateway, whatever we utilize here. We have the tier 1 gateways inside the organization, and on the side here we have our NSX-ALB environment, and our NSX-ALB environment is connected to the service interface of my tier 1 gateway, and there is where the magic happens with the whole load balancing story. So what will also be automatically provisioned is the service interface on the tier 1 gateway connected to the NSX-ALB service engine, and then there is where the whole load balancing stuff is consumed. So what the customer also gets out of the box when he utilizes CSE, or when he provides his Kubernetes clusters via CSE, is load balancing features. So he can immediately publish his applications, his containers with a load balancer, and everything will be automatically configured via Cloud Director. So this is also the reason why we need to have the API entry point via Cloud Director to the NSX-ALB service engine. Also the installation process, and this is really something I get highly excited, to be honest, with the latest release of 4.1, is now really straightforward. This is what VMware really has done well. As you can see, CSE management is now fully integrated into Cloud Director, and you more or less get a step-by-step guide where I say, hey, okay, please download and upload the necessary OVAs, setting up the CSE server, which is an Linux box, create the sizing policies. So what are my recommended cluster sizes, which maybe can be additionally changed or maybe can be improved, depends what the customer really requires. My personal recommendation on this is start really with a small, just have offering up to 5, a small setup, a medium setup, a large setup, and an extra large setup. It makes no sense that we always try to solve any customer issues. So it makes no sense to have 1,000 profiles or templates and say, hey, okay, you can have 1 CPU, 2 gig memory, you can have 4 CPU, 8 gig memory, whatever. Try to do it as we have done it with our virtual machines. We have t-shirt sizes, and this is what the customer can consume. And then we start with our admin role, with the creation of the admin role, which can be from time to time a little bit of a pitfall, because we all know, for those who playing around with Cloud Director, that role-based access management and Cloud Director are sometimes a little bit tricky, but it is also here, it is really well documented. And then we can start our CSE server and consume it. What have we learned, or what have we seen from installation in the field? What are more or less really the biggest pitfalls? On one hand, what often gets overseen, especially at the beginning, is yes, the Kubernetes as a service cluster needs access to VCD, so we need to provide the API access. This was the reason why we need to have the firewalls in place. DNS NTP as always, so if it is not DNS, then it is NTP. This is something which should be working. The customer needs one additional free IP address to provide the API access, so he needs to have a public IP address available. Load balancer is not configured on the edge service gateway, so this is one of the biggest pitfalls that you need to go to the edge service gateway of the customer and enable load balancing service, and the customer needs to approve, hey, okay, I will able to pay for load balancing. There is also a limited number of services available on the service engine, which cannot be configured from a cloud director perspective. This needs to be configured inside the NSX-ALB. So the error you get in cloud director is clearly telling you, hey, there are no services available anymore. And you figure out, okay, what the hell, where can I configure the service limit? You need to go to NSX-ALB, and there is the service limit. And the next problem is the API timeout. So we need to ensure that communication between CSE, Cloud Director, and also the custom Tanzu Kubernetes grid clusters is not timing out. The default limit of the API is sometimes a little bit too low. So you need, my personal recommendation is to increase it to 30 minutes, because after 30 minutes, normally a Kubernetes environment will be deployed. One thing we cannot solve at the moment is if you have a customer which is using Cloudflare in front of his VCD environment at the moment. We don't know if it is really VMware related or Cloudflare related, because I have at the moment two cases open, one on the Cloudflare side, one on VMware side. With Cloudflare, something weird is going on. So I cannot really solve it, but also a colleague of mine has the issue. So maybe just have a look, because I assume that in the next couple of weeks there will be an article available, maybe on VMware side or maybe on Cloudflare side, what's going on here. I hope they can solve it, because I need this really from one customer this week. I hope they can solve it immediately. As always, especially when it comes to NSX, please have verified the maximum transfer unit size. At least if you go with just 1,600, which is supported and okay from an NSX perspective, since Kubernetes also utilizes an overlay network, please ensure that you have at least 1,700. Always my recommendation is go with 9K and be happy, but if you just figure out, okay, we go with a smaller MTU, for Kubernetes you need to improve it as well. And as already mentioned, permissions inside VCD, so sometimes role-based access can be a little bit tricky inside VCD. I just got the confirmation last week that VMware is now really solving this issue, so the whole role-based access should be fine in 10.6 or 10.7. Let's see what's going on here. Okay, Reinhard.
I think we are afterwards the session. You can find us here at the booth, so thank you very much for listening. And enjoy the show. There are a couple of next coming up days, right?
And if you have any questions, we are around here right now, so just join us. But now we will leave the stage.
Because we're
Thanks.
in short on time.